Welcome to a sim code. Hey friends, glad you could join me today. Make sure to like and subscribe for more. Let's start by discussing the concept of equilibrium index. Equilibrium index in an array is an index such that the sum of elements to the left of that index is equal to the sum of elements to the right of that index. Let's say we have an array ARR. An equilibrium index would be where sum of elements to the left of the index equals sum of elements to the right of the index. To solve this, we need to use a strategy where we avoid recalculating sums for each index, because that would take too long. Time complexity. Instead, we aim to calculate the sum from the left side and right side in a more efficient way using two cumulative sums. Let's dive into the code now. First, let's initialize two important variables. Total underscore sum, this stores the sum of all elements in the array. Left underscore sum, this stores the cumulative sum from the left side of the array up to the current index. Total sum of the array. Start with left sum as 0. We will loop through the array and for each index, check if left underscore sum equals the right underscore sum. How do we get the right sum? Well, the right sum is basically the total sum minus the left underscore sum. And the current element at the index because we have already counted it in left underscore sum. We calculate the right underscore sum at each index. Now, check if left underscore sum equals right underscore sum. If they are equal, then this is the equilibrium index. We return this index. Return the index as the equilibrium index. Update the left underscore sum by adding the current element. So, next time, the left sum will include the current element. If we complete the loop and do not find any equilibrium index, we return -1. This means no equilibrium index exists in this array. Testing the function with an example array. Now let's call our function and see if it finds the equilibrium index. Explanation of the approach in more detail. We start by calculating the total sum of the array, O(n). Then, we loop through the array once while maintaining a running sum of elements on the left side. For each index, we can easily compute the right sum by subtracting the left sum and the current element from the total sum. This way, we avoid recalculating sums from scratch for every index, making the approach much more efficient. If we find an index where the left sum equals the right sum, we return that index as the equilibrium index. If no such index is found, we return -1 to indicate there is no equilibrium index in the array. Time complexity. The time complexity of this approach is O(n), where n is the number of elements in the array. This is because we traverse the array only once to calculate the total sum and check each index. Space complexity. The space complexity is O(1), as we are using only a constant amount of extra space, just a few variables. Let's try another example to test it. No equilibrium index in this array. Equilibrium index should be at 3. Now run our code. I hope you liked this one. Make sure to like, comment, and hit subscribe.